whole lesson on it. Okay, so in this video, I'm going to go through implicit differentiation questions. Guaranteed that 10% of your exam marks will come from, your exam 1 marks will come from implicit differentiation. I've shown you, aside from this video, pretty much every year I've got in this booklet, every year. It's just there. So let's have a go, and I'm going to show you what I would do. So I'm going to press start on my stopwatch and go. So first of all, what we're doing is equation of the tangent. We notice that it has to be implicit differentiation because we've got x and y in the one expression. So how do I do that? Well, we've got to write d by dx of the left-hand side. X cubed minus 2x squared y plus 2y squared is equal to d by dx of 2. That's your first step. Don't go skipping steps. Now what we need to do is derive the left-hand side with respect to x. So therefore we can say that 3x squared. Now this is the tricky part. This is where students fall over. We've got to apply the product and chain rule, if you like, there. So what we've got is, what is the derivative of minus 2x squared? The derivative of minus 2x squared is minus 4x times the other thing, which is just y. And then the derivative of y is y dash. Y dash times minus 2x squared is minus 2x squared y dash. And what I'm going to say is I'm going to let dy dx equal to y dash. So I've just covered my butt there, haven't I? Okay, because now I can just use y dash everywhere. Plus, now the derivative of 2y squared is, if I let u equal y squared, then the derivative of that is 2u. But what is the derivative of u? So, yeah, it'd be like 2y. So what we've got is the derivative of 2y squared is 4y y dash. And then the right-hand side, the derivative of a constant is 0. Okay, so it's so far not that much work. Now I've been explaining along the way, so I'm going to stop explaining. First of all, we're going to get y dash as a common factor. And we've got 4y minus 2x squared on one side. And on the other side, I'm going to have negative 3x squared plus 4xy. Therefore, I'm going to say y dash is equal to minus 3x squared plus 4xy over 4y minus 2x squared. And it says find the equation of the tangent. The equation of the tangent at this point here. That's just going to, this is going to give us m. So what we're just going to say at 2, 3, y dash is equal to minus, that's minus 12, 2, 8, plus 24, minus 12 plus 24, over 4 times y, which is 12 minus 8, which is 4. Is that right? Yes. Okay, so therefore I've got 12 on 4, which is equal to 3. Now what have I found? I've found the equation of the tangent is this. The equation of the tangent is equal to, we could say, is y is equal to 3x plus c. Yeah? We've found the gradient of that tangent. Now I've been given a point, 2, 3, haven't I? Yeah. So therefore we're going to now say that when x equals 2, y is equal to 3, which therefore implies that, I'm just going to skip a step, what does c equal? C is equal to negative 3. So therefore I've just done this in 3 minutes and 45 seconds, and I'm going to stop there, and that's with explaining it along the way. You guys have 4.5 minutes without having to explain it. So, y is equal to 3x minus 3 is the equation of the tangent. Put a little box around it, nice and easy. Happy with that? Okay, good. Now, there's not that much work. A lot of the time they give you a fair bit. I'm going to now pause the video and show you another question. I'll just find the question for you. There we go. Can you please have a go at this question? It's from the 2008 exam. It's worth 4 marks. Away you go. I'm going to give you 6 minutes in the exam. I'm going to give you 7 minutes. Zoom. All right, so first of all, if I was in the exam doing this question here, I would be doing this. I would be saying gradient and giving that a highlight. Gradient of the normal. Because when I first was doing this, just doing the solutions, then I took a fair bit of time finding the equation of the normal, which I could do, but it was just wasn't needed to be done. So, given the relation, so once again, my first step is doing d by dx of the left-hand side. Is equal to the derivative with respect to x of the right-hand side. Thanks. So now I could therefore say the left-hand side is equal to 6x plus the derivative of 2x is 2. 2 times y is plus 2y. The derivative of y is y dash, so it's 2x y dash plus 2y y dash is equal to 0. First step done, and I'm going to say that let dy dx is equal to y dash. Awesome. Now, I'm going to now get y dash as a common factor, and I'm going to say that 2x plus 2y is equal to, and I'm going to get the other stuff on the other side. I'm going to have minus 2y plus 6x. All right, now, so I'm going to therefore say that y dash is equal to, I'm going to divide both sides by 2. So I'm going to have y plus 3x with a negative out the front over x plus y. Is that right? Hope so. Now, I found y dash, and it says find the gradient of the normal at the point where x is equal to 1. Well, what we're going to say is that when x equals 1, we need to plug that, and you wouldn't do this in here, but you need to plug that into this relation here. So we're going to do that. When x is equal to 1, we've got 3 times 1 squared plus 2 times 1, which is 2y plus y squared is equal to 11. When I first did this, I think I wrote 1 there accidentally and then started going off on some big tangent because I couldn't work it out. So be careful. Y squared plus 2y minus 8, is that right? Is therefore equal to 0. And we can just factorise that. Y plus 4, y minus 2 is equal to 0. Which one of these is in the first quadrant? Awesome. So we can say that when x equals 1, therefore y is equal to 2, and we can just say first quadrant. If you did that, the examiners are happy that you've taken that into account. So now what we want to do is, it says find the gradient of the normal. So what we want to say is y dash at, 1, 2. And we're going to just sub that in, and we're going to say y dash at 1, 2 is equal to, y dash is equal to minus y, which is, 2 plus 3, over x plus y is 3, which is equal to negative 5/3. Now, remember that because it says find the gradient of the normal, so therefore, oops, I've lost my little pen for a second there. Therefore, we could just write out our answer. You don't have to show y or state the rule or anything. What's going on? What is going on? Okay, let me just put... Okay, therefore the gradient of the normal is 3/5. I just had to pause it. It just stalls sometimes. Is that okay? Yep. Good. All right. Now I'm going to just show you one more. Okay, let's have a go. No, that one's pretty easy. That's fine. Let's just do another one. That one's just straight differential calculus. Yeah, let's do this one. All right, I'm going to pause the video now, and I'd like you to have a go at this question in 3 minutes. I'm going to give you just 4 minutes to do this one. So try to do it as quickly as you can. Go. Okay, so I'm going to quickly go through this question. Find the gradient of the curve. So we're going to use implicit differentiation again. So our first step is this, as I've done in the previous two questions. Uh-oh. Uh-oh. Okay, so we've got this d dx of, oh, here it goes, doing this thing again. All right, so that is the derivative of the left-hand side is 2x, and the derivative of that, what have we got? Well, if I had like x minus 2 all squared, we know that we would have to, it's that 2 would come out the front, wouldn't it? So let's just say minus 2 over 4. And then we know that it's y minus 2. Yeah? And then y dash? Yeah? Is that it? Yes, good. Is equal to 0. And so therefore what we're going to say is that minus 2x minus y minus 2, there's a negative out the front, so minus y minus 2 over 2, y dash is equal to 0. Okay, so now I'm going to get y dash by itself, so we're going to say that y dash is equal to 2x, or let's say 4x, over minus y minus 2.
Hang on, why has it gone from 2x to negative 2x all of a sudden?
Where? 2x. Okay, I don't know where the hell that come from. Yeah, that's right. 2x. Oh no, because that 2x is then going over to the other side.
Yeah, but that should be negative on the other side because it's positive on the line above it.
Yeah, up here. So 2x. Oh, let me just see this. 2x over the other side times 2 is 4x divided by minus. No, that's okay. That's right.
Yeah, but from the second to the third line, a negative appeared in front of it.
Over here.
From the second. No.
Oh.
On the 2x, it becomes 2x. On the
Oh,
second line,
okay.
it's
Yes.
a negative 2x on the third line.
All right. Yep. Sorry. So, therefore, negative 4x, like that. So therefore, that's going to cancel each other out, and we've got y dash is equal to 4x over y minus 2. Okay, thank you. Now, at the point where x equals 2, so what we've got to do find now, and where y is less than 0. So what we're going to do is plug it into the original equation. At x equals 2, what we're going to say that 2 squared, which is 4, minus y minus 2 all squared. 4 is equal to 1. Rearrange. We've got 4 minus 1 is 3. 3 is equal to, 3 times 4 is 12. 12 is equal to y minus 2 all squared. Square root of both sides. 2 root 3 is equal to plus minus, no, just 1. Y minus 2. It is plus minus, isn't it?
Yeah, but we don't know that.
Yeah. So therefore y is equal to 2 plus or minus 2 root 3, and it's the positive or the negative. It's the negative.
Yeah, but you have to explain that to examples. You don't want to do that.
Since y is less than 0.
Yeah, just do that. That's like
Okay, now, we're just trying to do it this. Look, we could argue about how to do it so many ways, but at the end of the day, as long as we get full marks, you can do it your way if you like. Now what we're going to do is we've got to find, we know what y is equal to. So, therefore, we want y dash, find the gradient of the curve, that's fine. We want y dash at the point 2, and 2 minus 2 root 3. So I'm going to then plug that into that. So therefore we can say that y dash is equal to minus 8 over minus y minus 2. So we've got, 8. 8, I was looking over here now. 8 is 2 minus 2 root 3, yeah? So which is equal to minus 4 on root 3. You don't need to rationalise or anything. That's your answer. Is that right? Awesome. Sweet. Well, I'm going to stop there. Probably went longer than I wanted, and I hope that you've got enough from that to do these questions in the future. There's a good probably 10% on most of your exams. Exam 1 is on this stuff, so it is very important, and I guarantee you it's going to be on your SAC. So make sure you revise it.